Best greetings, dear students everywhere again, engineers and doctors. We are in question 4 of M1 paper, January 2025. Hopefully continuing crystallizing all questions and concepts in this paper. Since it was a bit dense paper, stay updated because I'll be solving maybe, God willing, 3 times a week, not only once daily, weekly. Variant level of the different like past papers for M1, Pure 1, P2, P3, P4, S1, and so on. So you are in question 4. Question 4, you are given in this question, the question very clear according to our experiences talking about moments. But this doesn't prevent that we have to read the question carefully, each question. A uniform rod AB has length 3 meters and weight W newtons. The rod is suspended by 2 lights or light vertical ropes. So we'll be having tensions then now. One rope is attached at A as shown, the other one at C, where the distance between A and C is 2.1 meters. The rod is in equilibrium in horizontal position. You are given the tension in the rope at C is 350 newtons. So directly you come here, 350 newtons. T at C, T at A. Show that the weight, W, which is the weight of the rod, is 490 newtons. We can do this question in many ways, but we have to do the shortest way to get the full 3 marks. Usually we have to write two equations of forces, equations of moments. Usually we have to build 2 equations to be solved simultaneously, but taking the moments only is enough for this question and this question. What do you mean, sir? I mean, take the moment. We are free, to take it about any point we want. So we'll take the moment we prefer for the most of the questions at the ends of the rod. So I will take it at A. So this means the tension at A, the moment of the tension at A is 0, since the distance is 0, leaving only 2 forces, tension at C and the weight of the rod. Let me make it a bit neat, which is W, which is 1.5 meters, since the question from A, since the question says a uniform rod. So this means weight, the center of mass is in the middle. The center of mass is in the middle. It's 3 meters long, so W is 1.5 far from A. This will tell now, you come here better for you. We decide to take the moments about A, draw the direction, just is it clockwise or anti-clockwise, like this, small arc. So you will recognize that this one is clockwise, this one anti-clockwise. So moments clockwise or anti-clockwise, you are free. Then you come and write the equation by calculating the moments of each 4, which are 2 forces. W 1.5 from A, the other force 350 newtons, which is 2.1 from A. Multiplying 350 times 2.1 divided by 1.5, you'll get the answer. Simply and fast like this. A particle B for part B. Once You read the question, guys, as I did, prepared for you to save your time. Once the question says start the particle P of weight 200, so new information. Sketch directly new information on the next page. So a particle P now of weight 200 is attached to the rod at a distance d meters from A. So for example, this is particle P here. Label what are you reading and doing, d meters. Neatness sometimes helps us to get the right answers faster and easier. The tension is now at rope of the rope at C is 600 newtons. And this is W, which is 1.5. It will not change. The rod remains in equilibrium and now is in the same horizontal position. Find the value of D. Sketch the information here. Discuss the equation in different way because there's new information. Better here. Remember, we can take the moment about any point on the road we want. Taking it since the question say P is d meters from A, so this indicating to us, telling us in implicit way, take the moments at A and labeling this. You'll help yourself and the examiner to be involved more in what you are doing. So we have now three forces. You decided to take it A with the same concept. You come here like this, show the direction to yourself, and he gives us here like this. And he told us, this force is 210 newtons. Let me just make it more clear. So only that will do the sum of moments anti-clockwise is equal to the sum of moments clockwise. So we have only one force anti-clockwise, which is 600 newtons. That is far from A, 2.1, as he gives me in the beginning, equals to W, that is far 1.5 from A, and 210, which is D from A. We know from part A this is 490, so 600 times 2.1 equals 490 times 1.5 equals 200, and D, by multiplying in the calculator and solving, so you get 200, and D is equal to 1,260. Multiplying these, you will get 735, which is 525, dividing by 210, you will get 2.5 meters from A. So D is 2.5 meters from A. Part C is saying the particle P now is removed from the rod. Another new information. So look, I did here, prepare, check, test yourself and draw a new sketch. The rod remains in equilibrium. The particle Q of weight X newtons is now attached at B. So this particle Q here now with force X newtons. This is W as it is, which is 1.5 meters from A, and Mr. TC stays as it is. The rod remains in equilibrium but in horizontal position and now on the point of tilting. Find X. Usually the question in the moment questions, tells us, guys, the point of tilting. But here is very clear. The P was here is removed, is totally removed. And now we have a new particle with weight here close to C. So directly we deduce that the rod will tilt about C, because a new force close to C, very close, which is 0.9 meters. So very close, so it will be tilting about C. Once you recognize that the rod tilts about C, you come here directly without thinking. You take the moments at the point of tilting. When you decided, or when you decide taking the moment at C, directly the T at A and the tension at C both zero. T, the rope, because it's on C, so it will be zero, and also T at A will be zero. If you don't see this very well, I will show you a small sketch here. This is that will happen. This is C, no tension here. The rope will be removed. No effect for the rope now for at A. So directly leaving this with two forces, only two forces left. You stay the direction. So X is the clockwise one, equals the moment anti-clockwise. X Newton is far from C, 0.9 meters. The other one is W, which is 490. From here to here, 2.1, leaving the distance here 0.6 for 90 here. Solving this for X, so 0.9x is equal to 294. So X equals, in the calculator, 980 over 3, which is 326.6. Be caring or repeated. I hope that I make always difference to you in the understanding, crystallizing the concepts of the questions that we do, leaving you with well and safe.